Alright everyone, so going forwards with sets, we have learned some way to describe sets, which was our set notation, and now we should discuss a bit about our interval notation. So what is the interval notation? Well, basically it's a way to allow us to quickly describe sets using mathematical symbols only. So we're not going to use words, we'll only use letters, numbers, bigger, larger than, greater than, less than, equal to. So let's take a look at one example. So here I've got this interval notation, and basically what does that mean? Well, it means x such that x is larger than -3 and less or equal to 2, and x is a real number. Right? That's fair enough. So basically it's all numbers that go from slightly larger than -3 all the way to 2, including 2. So here there's a bit of information which is too much, and sometimes we don't have to write it. So here x is a real number, right? So if you remember our sets, the special sets that we dealt with in our last video, so this now is x is a member or is an element of the real numbers. So this is our special set, our special number set. When this is omitted, it basically means that it's assumed that this is a real number. So sometimes you can just see this, you may find this in the problems or in the questions, IGCSE questions, and basically it's implied that x is a real number, so you don't have to write it. When x is a real number, you can just omit, and if it's not written, then you can assume that it means that it's a real number. So we could also represent this same example in our number line. So if we plot our number line, we would observe here that we've got all numbers which go from -3 but not included all the way to 2, including 2, because this is less or equal than. So this point here is filled in, and this point here is not filled in because -3 is not included. So we could also take a look at some examples. So here we've got a slightly different situation, okay, and basically it's a interval notation, and we've got a number line. We want to write this in an interval notation. It's slightly different than the problem that we have here, because if you notice, we don't have anything between the numbers. So this would be 1, 2, 3, 4, and 5. Right? Now the problem here is that we don't have the numbers in between. So we only have the numbers that we can count. Right? So it's 1, 2, 3, 4, and 5. From what we did in the previous lessons, we could just say that, well, there's a set S, and I've got 1, 2, 3, 4, and 5. But that's not the notation that we want now. We want our interval notation. So we could just list this is equal to, okay, it's the same set. You're talking about a set, we're calling it set S. Now we have x, right? So, well, x such that, now x is going to be between a few numbers. So the smallest number that we have here is 1, but it's included. So x is greater or equal than 1. And now the largest number is 5, but it's also included. So x is less or equal than 5. And here we don't have all real numbers, right? All real numbers would be everything in between, but we don't have those intervals here filled in. So I'm not talking about real numbers. Here I could be talking about natural numbers or even integer numbers, but I'm not going to the negatives, right, since my interval is only positive. So the best for us here will be x is a natural number. Alright, it wouldn't be wrong if you had x is an integer. It would also be acceptable. Okay, exactly the same beginning here, but x is a member of the integer numbers. So let's go to a second example now. So we've got our number line, and we would like to express this in our interval notation. So I'll call now this, I don't know, set A, just to have a different letter. And again, look, let's call it x, such that now x is going to be between two numbers. Now, because it's in between, right? So our smallest number is take away 3, and it's included. Our largest number is 6, and it's not included. Here we've got everything in between, so it's a real number. We could either express this as x is a real number, or you could just omit. This would be another possible answer, x such that x is between take away 3 including and 6, and that's it. When nothing is written, it implies that all numbers in between are included. So for our last example here, let's take a look at this one. So first question, list the elements of the set x such that x is between -2 and 1, including them, and x is an integer, right? Is a member of the integer set. So if you remember integers, they are 0, plus or minus 1, plus or minus 2, plus or minus 3, all the way to plus or minus infinity, right? So if we are looking at numbers which are between -2 and 1, so let's call this set B. So in this case here, A1, our set would be -2. What's the next number? -1, 0, and 1. That's it. So those would be the elements of this set. Now what about the follow-up question? So here we're talking about natural numbers, so it's even easier, right? It's really similar to the integers. However, for the naturals, we only have 0, 1, 2, 3, and so on. It's only the numbers that we could count with our hands. Alright? In this case, we're going from 0, including 0, all the way to 4, but not including 4. So what would be our set here? I'm calling it set C. You can give whatever name you would like, as long as it's a capital letter. Now, x here, is 0 a natural number? Yes, so 0 is there, right? X is greater or equal than 0, so 0 is there. The next one would be 1, right? Is 1 less than 4? It is. Is 2 less than 4? Is 3 less than 4? Is 4 less than 4? No. And 4 is not included, right? That's why if this was also equal to, right? So if we had a symbol here equal to, we would have 4 here. However, since it's not, that's our set. Those would be our elements. Alright? So last problem here, writing interval notation. So we have -3, -2, -1, 0, 1, 2, 3, 4. The first thing that you would have to look for is what kind of numbers are you talking about here? What kind of special sets? Would those be natural? Of course not. Why? Because we have negative numbers. Would those be integers? Well, it seems so. We don't have any fractions. We don't have anything between whole numbers, and we have negatives and positives. So that should be okay. So the integers would be okay to describe those numbers. So let's go for a set. I'll call it set D now. So we would have x such that x. Now, x is going to be between two numbers, right? I'm going to describe them as larger or equal than, or greater or equal than. So the lowest number that we have here is -3, and the largest one is 4. And those numbers, they are integer numbers. So they are members of the special integer set. Now there's another way to describe those. This is the way I would recommend. However, you could also describe as greater or equal than and not including them. So what you would have to look for here, if you draw your number line, x, going to both sides here, right? So take away 3, take away 2, take away 1, 0, 1, 2, 3, 4, 5, and here take away 4. So let's observe all of those numbers here that I've drawn from -3 all the way to 4, they would be included, right? So if I pick a different color here, so this is included, this is included, this is included, so 0, 1, 2, 3, and 4. So if I want to describe just as larger or lower than, greater or lower than, do you notice that, well, this would be -4. Because what is the next number, the next integer number that is greater than -4? It's -3. And here we could also describe this as, we could also place a 5 here, and then it would be just less than, right? So x is less than 5. It's not less or equal than. It would be less or equal than 4, but it's less than 5, since we are talking about integer numbers.